Alright, so this morning we're going to look at the factor label method, and the factor label method makes use of conversion factors. Conversion factors are equivalence measures that allow us to convert between units. So equivalent measures that allow us to convert between units. So an example of a conversion factor would be one pizza has 8 slices. Okay, and I'm going to write that in terms of dimensional analysis over top. One pizza, 8 slices, or 8 slices for one pizza. Notice I can flip-flop where my values are, but my number and my unit never change. So one pizza will always go together, 8 slices will always go together. So I've directly taken my equivalence measure and plugged it in directly as it's written. I haven't changed anything about it. So that's going to be very important when we look at converting between units, because you're going to want to make sure your units line up. So if I say that one pizza is equal to 8 slices, then writing it over top shows the same relationship. This is not a fraction, so I don't want you to think of this in terms of fraction. Fraction math, it's a little bit different than that. It's going to allow us to look at units and convert between lots of units. We're going to use it at many points in chemistry. So it's very important that you understand how to apply it. So before we start kind of diving in, I want to review some of the metric conversions. So King Henry died by drinking chocolate milk gives us our big 6 that we need to know. Kilo, hecto, deca, base, deci, centi, milli. Kilo is abbreviated K, hecto is abbreviated H, deca is abbreviated as big D, deci, little d, centi, little c, milli, little m. Now, when we start to do these equivalence measures for metric conversions, we can say that 1 base, or 10 to the third base units is equal to 1 kilo unit. So instead of B, let's use U. Well, we can just do that. 10 to the third base units is equal to 1 kilo. 10 to the second base units is equal to 1 hecto. 10 to the first is equal to 1 deca. And then decis are going to be, or the ones at the 3 at the bottom are going to be negative. 10 to the first is equal to 1 deci. 10 to the second is equal to 1 centi. 10 to the third is equal to 1 milli. The ones are always going to go with your prefix unit, and the 10 to these are always going to go with your base units. So these are my base units. These are prefixed. So my base units include Newton, gram, liter, second, any base unit that you can think of, we can put a prefix on that. Okay, so any of your SI units. So when we go to work problems, well, I think there are 3 more you need to know, yeah. Micro is 10 to the negative 6, nano 10 to the negative 9, pico 10 to the negative 12. Pico is abbreviated as a lowercase p, nano is abbreviated as a lowercase n, micro is abbreviated as a Greek U. Those are your other 3 that you have to know. All right, so let's practice. So before you start doing the actual math, what I want you to do is write the equivalence measure for your units. So I'm starting in milligrams. Your starting point will always be a number associated with a unit. Number and unit is where I start. And my ending point is always going to be represented as an empty unit, so a unit without a number. So my starting point is 3,500 milligrams, and my ending unit is going to be grams. Starting point, ending point. Now, what's the relationship between milligrams and grams? Well, 1 milligram equal to 10 to the third grams. So when I go to set my problem up, I take my starting point directly out of the problem, 3,500 milligrams, and I put it over 1. I always put it over 1. 1's just a placeholder. Okay, then I can use my equivalence measure to convert between milligrams and grams. So think about polynomials where you have values on the top and the bottom, and if they're across from each other, you can cancel them out. The same is true of units with dimensional analysis. So the unit I want to cancel needs to go opposite where it currently is. So if milligrams is on the top in conversion factor 1, it's going to go on the bottom in conversion factor 2. So milligrams goes on the bottom. Well, if I look at my equivalence measure, the only other unit I have is grams. So grams has to go on top. And then I just plug my values in like they're related. So 1 belongs with milligram, 10 to the third belongs with gram. Milligrams cancel, I'm in grams. At this point, I can solve. 3,500 times 10 to the negative third gives you 3.5 grams. Now you can go back and check using the rules you were taught in earth science and middle school, 1, 2, 3, and find the same answer, but I need to see the work. The work is what you get credit for. Now the next one says convert 0.649 liters to kiloliters. So before we start, let's identify our starting point and our ending point. Starting point is the number associated with a unit. Ending point is an empty unit. And write our equivalence measure. 1 kiloliter is equivalent to 10 to the third liters. 1 always goes with your base unit. 10 to the whatever always goes, 1 goes with your prefix unit. 10 to the whatever always goes with your base unit. Take your starting point, 0.649 liters over 1, and then look at your equivalence measure. I have liters and I have kiloliters. I know liters has to go on the bottom, which means the only other unit, kiloliters, has to go on the top. Look and see what's married to what. 1 is married to kiloliter, so it plugs in front of kiloliters. 10 to the third is married to liters, so it plugs in for liters. Now, how do I solve here? Multiply by the top, divide by the bottom. So 0.649 times 1 divided by 1 divided by 10 to the third gives me a value of 6.49 times 10 to the negative fourth kiloliters. Again, I'm going to move 1, 2, 3 spots so I can see that my number would be essentially the same. Multiply across the top, divide by the bottom. Make sure you're tracking your units so that you can cancel them. Alright, let's work a couple more. 84,345.6 micrometers to meters. So let's identify our starting point and our end point. And then let's write our equivalence measure. 1 micrometer is equal to 10 to the negative 6 meters. So we can take our starting point, 84345.6 over 1. Starting point always goes over 1. Micrometers has to go on the bottom, so I can cancel it. The only other unit I have is meters. It has to go on top. Then I just plug in the values where they belong. 1 is married to micrometer. 10 to the negative 6th is married to meters. Micrometers cancel. I'm left in meters. The question wanted meters. I can solve. So I'm going to do 84,345.6 times 10 to the negative 6th divided by 1 divided by 1, multiply across the top, divide by the bottom. My answer is 0.0843456. Make sure you have a unit on that. Meters. Alright, one more. 57 milliliters to liters. 57 is my starting point, a number and a unit, and liters is my ending point, an empty unit. I know that 1 milliliter is equal to 10 to the negative third liters. Take my starting point and put it over 1. Starting point always goes over 1. Look to see where milliliters needs to go so I can cancel it. It's got to go on the bottom. If milliliters goes on the top, liters has to go, if milliliters goes on the bottom, liters has to go on the top. Now plug in the values. 1 milliliter, 10 to the negative third liters. Milliliters cancel, I'm left in liters. Problem wanted liters. Multiply across the top, divide by the bottom. 57 times 10 to the negative third divided by 1 divided by 1 gives me 0.057, and make sure you have a unit, liters. Factor label method is, the hardest part of factor label method is figuring out what your equivalence measure is. If you can figure out what your equivalence measure is, then you should be able to track your units, use them as a roadmap to figure out where you need to go. Alright, two-step conversions. The base unit is not present in answer or given in the starting number, so I have to take my starting point, the given, go to base, and then go to ending point. Okay, so you're going to have to go to base, go through base for each of these problems. What's base? It's an unprefixed unit. So if I look at this first problem, 0.46 milligrams to kilograms, 0.46 milligrams is my starting point, kilograms is my ending point, and I'm going to have to go through base to get to convert between those two units. So let's write our equivalence measures. I know that 1 milligram is equal to 10 to the negative third base, or gram, and I know that 1 kilogram is equivalent to 10 to the third grams. Once I have my equivalence measures, I can just start, I can set up my problem and start solving. I know that the base unit is gram because it's represented by a G, okay? So I take my starting point, 0.462 milligrams over 1. Look at your two equivalence measures. Which one has milligrams in it? Well, it's the first one. So I know that bottom's milligrams, and the top has to be grams. It has to be the other unit represented in the equivalence measure. Plug in what belongs with what. 1 belongs with milligram. 10 to the negative third belongs with gram. Milligram cancels. I'm in grams. I've used this equivalence measure. Now I only have one equivalence measure left. Does it have grams in it so that I can cancel? It does. So if grams goes on the bottom, kilograms has to go on top. Plug in the value. 1 belongs with kilogram. 10 to the third belongs with gram. Grams cancel. I'm in kilograms. Problem asked for kilograms, so I can solve. Multiply across the top. Divide by the bottom. 4.462 times 10 to the third times 1 divided by 1 divided by 1 divided by 10 to the third gives you the answer of 4.62 times 10 to the negative 7th kilograms. And I'm done. 880,000 decimeters to, we will go to kilometers here. We'll go to kilometers. So cross out the big M and go to kilometers. So again, I'm starting in deci. I'm going to have to go to base, and then I'm going to go to kilo. So this is my starting point. This is my ending point. And I have to go through base to get there. So let's write our equivalence measures. 1 decimeter is equal to 10 to the 1 meters. 1 kilometer is equal to 10 to the third meters. Once I have my equivalence measures, take my starting point, put it over 1, because it always goes over 1. Okay, my starting unit is decimeters, so I need decimeters on the bottom. Find the equivalence measure that has decimeters in it. So if decimeters is on the bottom, meters has to be on the top. Plug in what belongs with what. 1 decimeter, 10 to the negative first, and now I've used that equivalence measure. Decimeters cancel, I'm in meters. Find the equivalence measure that has meters in it. What's the second one? Meters goes on the bottom. Kilometers, the only other unit there, has to go on top. 1 kilometer for every 10 to the third meters. Meters cancel. I'm left in kilometers. The question asked me for kilometers, so I can solve. Multiply across the top. Divide by the bottom. So 880,000 times 10 raised to the negative first times 1 divided by 1 divided by 1 divided by 10 raised to the third gives me a value of 88 kilometers. So that's essentially 1 and 2 step conversions. The only other conversion we're going to look at is complex unit.